Hello, and welcome back to More on Maths. In today's video, we are attempting question 16 from the AQA AS Mathematics Specimen Paper 1. For this first part, we have to find an expression for the force acting on the particle. We're given the mass, and we're given an expression for V. One equation which links force and mass is F equals ma. So we just need the acceleration now. To get this acceleration, we can simply differentiate this velocity expression here. To do this, we drop the power of a 6t squared and times the 6 by the 2. Do the same again here, drop the power, 12 times 3, negative 36. So now we've got the acceleration, we can multiply it by the mass, which we need to convert from 400 grams to 0.4 kilograms. That's our standard unit for mass. So force is equal to 0.4, and in the brackets our acceleration expression. We can multiply that out. 0.4 times 12 is 4.8 t. 0.4 times negative 36 is negative 14.4. We've got t squared. So there we have it, force in terms of t. Now we can move on to the next part. Now we have to find the time when the particle next passes through O. We're told at the start of the question that the particle is initially at rest at the point O. So we know that when t is equal to 0, the displacement is 0. We can work out the displacement, or an expression for the displacement, by integrating that v expression above. So there's our v expression from earlier. If we integrate that, that will equal the displacement. We'll raise the power to t cubed and divide the coefficient by this new power to get 2t cubed. We'll raise the power again to t is 4 and divide that negative 12 by this 4 to get negative 3. We also can add c, but because we know the displacement was 0 when we first started, the c is equal to 0. Because we want to get when the displacement is equal to 0, we can rewrite here, equating it to 0. Now we just need to solve for t. We can factor out t cubed, leaving in the brackets 2 minus 3t, and our two solutions for t equals 0, which we know from the start of the question, and t is equal to 2/3. It's a time, so that's in seconds. So there we have it. The second time where the displacement is 0, where the particle next passes through the origin. Feel free to check out the rest of our More on Maths channel, where we'll be posting more walkthroughs like this in the future. Thank you for watching.